Morning, folks. Thursday, May 21st here, kind of near the end of it all, so to speak. Um, Today, what I want to do is I want to talk you through convex mirrors. All right. We spent Monday and Tuesday talking through concave mirrors. That's where it was wider at the top and skinny in the middle. Okay. So today will be just a different version of that now. Okay. All right. So concave mirror, just to clean up, I wanted to give you some insight into what's the actual application of these. The kind of why does it matter if we know what a concave mirror is or isn't. Um, you, my wife has one of these in on her side of the bathroom, and yesterday when I was trying to look for a spot to be able to shoot a laser through a mirror, I picked it up, looked at it, and holy man, the one side, once I got into the correct distance of it, whew, man, I could see every single pore on my face, so to speak. Okay, so that's going to be a concave mirror for us. Headlights or flashlights. Um, Headlights actually have that single bulb on the inside of them, and then you've got a concave mirror that's going to shoot that out. Now they have other pieces in there that allow it to kind of deflect a little bit more and spread out, so it's not just a single parallel location for us. Okay, but headlights work the same way, and then dental mirrors. So if you get to go into the dentist sometime soon here, um, what they'll do is they'll put that little mirror inside, and that's basically going to be a concave mirror for us. It's going to allow them to see a bigger version of what's going on inside your mouth, so to speak. Okay, so those are our concave mirrors. So convex mirrors now, these are a little bit more challenging. Um, when we ran thin lenses and stuff like that, we saw that there were some challenges with both of those concave and convex lenses there as well. So with a convex mirror now, it gets a little trickier, all right? So we can't forget our rules. Now, first rule, parallel to the mirror and then through the focal point. The second one is through the focal point and then parallel. Remember now, when we're talking parallel here, we're talking to the principal axis, right? That dashed line that has the bottom of the object there. And then number three, right through the center of curvature of the mirror, all right? Now, a couple questions for you. Can the light get to the focal point or the center of curvature? Meaning that when we look at this light being shown through here, something to think about is this. Ooh, let me get my, come on. There we go. All right. So when we shoot this light this way, right, as it hits the mirror, is it going to be able to go through to this backside here? It shouldn't, right? Because the mirror is going to have some sort of a solid backing to it. Yes, now there's one-way mirrors, right, where you can see through them, and those have those purposes in businesses to allow people to observe their customers while keeping their office areas private, so to speak, right? But for us, the majority of the mirrors that we're going to work with are not that. Okay, what ends up happening is that this light should not make it through there. All right, so here we go. First one, there's our parallel to the mirror, right? So then we ask the question, now what, right? What should happen here is that once this hits this mirror, right, it should reflect, just like we saw in the entry where the dog and the cat were seeing each other or seeing themselves in the mirror, right? That light from them is going to bounce off and come right back towards them, right? In this case, if we look at seeing somewhat of our normal here, right, what we should see is this thing should bounce off and away. It cannot get bent in and go through. So what we have to do is say, well, what is our second part of the rule? The second part is based on that focal point, right? So we see there's my focal point. That's the direction, that's the angle that this light ray has to take. So we finish it off by drawing that up that way. Okay. Now, does this light here actually exist? It doesn't, because it can't, right? So what we then see is, all right, let's get the next one. Now, question for you. Can that actually happen? Can this thing go from the tip of the pencil all the way through the mirror into here? No, you should be saying, right? Again, once we hit this point right about there, it should do what? It should reflect, right? That's the key. Because that mirror, as soon as that light hits, it's going to bounce a different way. So then we say, why does the light stop here? Because that's where the mirror is. The mirror is going to create that option or that opportunity for that light to bounce, to reflect, to go somewhere differently, right? So then what we see is it should go parallel that way, right? Notice that's parallel to the principal axis, right? And that's, again, that second part of that rule. Okay? We also get that, meaning that does this light actually do this? No, that's why I dashed it. Okay? And what ends up happening is we see something kind of interesting, right? If we look back here, we've got two images or two light rays, supposed light rays, that are connecting. Now, if you look at our other parts, what you're going to see here and down here is those are diverging. Those are spreading out. They're going away from each other. There is not going to be an image on this side of the mirror. But if you look close enough, you should see that these are going to cross here. There should be an image there. All right? Add the third line in just for, uniformity's sake, just to be able to go through and do all the rules. But really, we don't need the third rule, right? That one will hit the mirror through the center of curvature. It'll bounce straight back out, right back out through our eye, right? And then we'll see that one goes there. Now, notice something here, right? This is not a perfect mesh. It's not a perfect location, right? The green one is off a little bit, all right? And maybe I'm splitting pixels here, but at the same point, I just wanted to be upfront and honest with you and say that sometimes this just doesn't work out the way we want it to. So, because all three meet there, that means that's the place where our image is going to form, all right? So when we see this image forming here, all right, the image is virtual. Why is it virtual? Well, remember, this is the actual light ray, this is the actual light, and this is the actual light. That's the real light that we see. What we have back here is not the real light. So when these three cross back there, you're going to see that as that virtual image for us, right? Because this is behind the mirror also. Okay, we can't have that image actually form behind the mirror, so that becomes a virtual one. It's upright because, well, it's on the same side as the image is, right? The image is upright, and this is upright. Remember, if it were to be upside down or inverted, right, that would mean that the pencil then is down like that, okay? Using the simulator that you're going to use later today, I just took the image, I just took the object, put it at about a +4 on the x-axis, right, with a height of about 1, and we see all of our different images, or all of our different light rays going away, right? Like that. And then what we get a virtual image there, right? So it's going to be upright, and it's going to be a virtual image, okay? Now, all these other things, they're nice. Distance of the object is 4. Distance of the image is -2. That just tells us that it's behind and it's virtual. Height of the object is 1. Height of the image is going to be 1/2. All right? And again, we don't necessarily need to calculate that or do anything with that. Just know that, this image is going to be small compared to that one. All right? Uses for convex mirrors. If you've ever worked in or been in a place where they're maybe running forklifts or traffic or something like that in a parking garage, even too, you'll see a mirror like that on the top, usually, so that you can see around the corner, so that you can look and see what's coming around that corner or what's coming down the other way if you have some sort of a blind corner. If you've ever been to MSP Airport and parked on site there, they have those all over the place for you, all right? On the right side, you got your side mirror, right? Objects in the mirror can be closer than they appear, right? Again, that is just meant to take something from a long distance and simulate that you can see exactly where it is on the back side of this. Well, unfortunately, on the back side of this, there isn't anything. Okay? All right. Homework for the day. Check out Schoology or the Google Drive link that I'll put out there on the email with you. For this one, it's basically using that simulator to draw different objects and to create um, different ways of using concave and convex mirrors. Okay, you can work with pairs or threes, whichever one you want to, if you want to do that. All right. Otherwise, don't forget, got a quiz tomorrow. Quiz tomorrow will be on concave, convex mirrors as well. All right. Nice short 5-question one. Nothing that you haven't seen so far. All right. If you got questions, let me know. Otherwise, hey, take care. Have a great day. Hopefully, we'll see you soon.